Alright, so today we're going to talk about conditional statements. Have you ever heard of a UML diagram? So a UML diagram is basically kind of like making a picture of your program. I had a boss who wanted me to do diagrams for everything, and I hated it. But luckily I had a business analyst to do all that for me. There are some symbols, and they're in the book. There's this pill looking thing. That's where you mark your start and your stop. There's a rectangle that's just used for statements. There's a tilted rectangle that's used for I/O, input and output. And there's the diamond to ask questions. And all the symbols are joined by an arrow. So if we make our flow of our program based on these symbols, we just join as many as we need and we follow the arrows. Remember when we did our loan calculator and there was the possibility that you could have a division by zero? Right. So let me erase this. This is in the book anyway. So there's a chance, if you remember the formula, the payment was given by amount times the interest, periodic interest, divided by 1 minus 1 plus interest to the negative terms. So if the terms were 0, any number raised to the power 0 is 1, that was going to make our formula have a division by 0, which is not defined mathematically. So we can rewrite our program. I'm going to make pictures. I'm going to make a start. So we need the 3 variables. The inputs are the loan amount, the interest rate, and the number of payments, and the output was the monthly payment, right? So I'm going to declare my variables. I have the amount, the payment, and the interest. And those are doubles, right? I didn't fit. Those were doubles. And we have one that is the terms, which is an int, right? And then we ask the user, we say input the amount, the payment, and the interest. And then we ask if the terms, no, the payment, I'm sorry, we use ask the amount, the terms, and the interest. If we ask the question, terms are 0. The answer is yes. Then what do? You just display an error message, right? So there's no loan, it's basically making a cash purchase. No. Display an error. If the answer is no, then we proceed to calculate the payment. And after you calculate the payment, you display the monthly payment. And then down here, the programs join and the program ends. So it's easy. By looking at it, you follow the arrows, right? These are supposed to be arrows. And this diagram doesn't tell me exactly the code that I used to calculate the monthly payment, and formula is not shown. All I do is say calculate payment. So the idea of a UML diagram is to just give you an what you call it, high-level picture of what your program is. If you had trouble programming something, just make a diagram, what it's supposed to do, and then code the diagram. So we don't use yes or no in programming. What do we use?
True or false?
True or false, right? So if I declare a variable type boolean, how many bits do I use? Just one, right? 0 or 1. Well, the computer, what if I don't use 1 bit? What if I use 32 bits? Because that's what the computer allocates. If the middle bit is 1 and everything else is 0, is that true or false? Let me ask you again. So, false is, if I have a 32-bit system, false is gonna be okay, let's see, it's a 16-bit system. It's a Windows 95. So, true will be, I mean, I only need 1 bit for true, right? That. But what if I have something like this? Is that true or false? So what's false? All zeros, right?
Yeah.
Is this false? Then it's true. So anything that has a 1 is true according to the computer, because it's not false. The computer is not gonna say, what is it? It just says it's not a false. Then it goes as a true. Sometimes when you program, you know an integer is a 32-bit, right? Sometimes you might need multiple boolean variables, but you're only using the last bit, right? but the computer is going to allocate whatever the word size is, in this case 16. So you're kind of wasting 15 bits. And you're writing software, maybe you do an embedded software, maybe it's for a car or a robot or something. And it just happens that you might need 6 or 8, let's say you just need 8 boolean variables. You don't want to waste 15 times 8, right? That's 120 bits being wasted, and your memory is small. So what you do, you say, oh, my first bit is going to be the variable 1, this bit's going to be variable 2, this bit will be variable 3, and so on, right? So you can like have one variable, an integer maybe, and you use all the bits as the positions that you want. We're going to talk about that hopefully today, if not Thursday, how you do that. All right, so this part is easy, right? So what if instead of saying terms equals 0, 0, what if I say, is it true? Just write the word true. That's always going to be true, right? So that's not really a question. The computer doesn't know that. You put that true inside a diamond that's saying, are you asking me if true is true? So how do we code this? So let's put it back, terms equals 0. To code this, we're going to use an if statement. So the diamond is this, an if. And the if is a built-in function. Let's see. And because it's a function, it has parentheses. And inside the parentheses, we have what we call a logical test. Some books call it a condition. So it's just like a function. When we declare a function main, we use our curly brackets. We close the curly brackets. So if this condition is this question, returns a true, then executes this code. So whatever code you need to execute, if the condition is true, you write it here. Code to execute if true. If it's not true, then I need to have another section. I call it an else. And the else doesn't take any parentheses or parameters. Because if it's not true, then it must be false. There's nothing in between. So here's the code to execute if false. What if inside my if statement, if it's true, I declare a variable and I call it x. And I say x equals 5. If it's false, I say x equals 10. Can I do that?
No,
Why not?
you didn't define integer x in the else function.
Exactly. Because if this becomes false, this code never gets executed, right? So it goes straight to the else. X is never defined. Because x is defined inside this set of curly brackets. Therefore, I cannot use it outside of those curly brackets. It will be an out-of-scope variable if I try to use it somewhere else. All right, so what's a logical test? Anything that returns true or false. So I could be silly and just write the word true or the word false. So that kind that says this statement is always going to be executed, right? Because it's true all the time. This will never be executed. So you wouldn't really do that. In loops you may see that, and I'll explain to you why, but a different class. So we're not gonna use the word true. I could use a variable. Let's make some room here. So here's my logical test. I could declare a variable, type boolean, and I call it, I don't know, leap year. And I can say leap year equals false. So is it better? Alright, the word leap here doesn't show up. Guess I'm too high here. So I had it like this, boolean, then false, and I had if. So inside my logical test, I could just use the variable itself. I can just write leap year. Why? Because the variables is true or false. So this returns a true or false. I don't need to say is leap year true, because the variable itself holds true or false values. What if I'm not using a variable? What if I'm using an expression? So if I use an expression, I'm going to write it down here. That means I need to perform some sort of test. If I'm going to use a test, perform a test, I need to compare two things. And in order to compare two things, I need a logical operator. So there's a list of logical operators. I'm just gonna OPR, and I'm gonna write here opposite. So if you compare, if you want to compare two things to be the same, we use double equal signs. Because if we use one equal sign, what do we do with one equal sign? That's called the assignment operator. So if the computer sees only one equal sign, it's gonna say whatever's on the right side goes on the left. It's not a comparison. That's why we use two, to say this is a comparison. You're testing the values of the variables on the left and right, see if they're the same. What's the opposite? That will be not equal. And if you read your chapter before coming, what's the not symbol? The what?
Is it like in cross or equal sign?
Not in computer, that you can't. So to say not,
Equal and then the bigger sign? Greater sign?
no, is the exclamation. That's not. So not equal. I mean, you can get the book for free. You just need to read. You just need to read it. So, in the computer world, we say, you know, when you're a kid, you say, "I hate you, not," at the end. Well, in the computer, you put the not first. So not equal. Everything is not first. So obviously, if I say greater than, usually nobody tells me the right answer. What's the opposite of greater than?
Less than?
No. See?
Equal. Oh,
What is it?
equal to.
No. I got excited for a second. Is less or equal the opposite? Otherwise, you exclude the number in the middle. So then the greater or equal, the opposite is less than. It's just the same. So in our test here, we're not using the variable now. If we were using our loan calculator, our test is if the terms are zero, right? But in our diagram, I only use one double equal sign. But in here, if I remember correctly, we call it I-terms, right? So it would say if I-terms equal 0. If it's 0, then you're just supposed to display an error message. So I just do a printf terms cannot be 0. I had a student who really wanted to annoy the users and put some really derogatory messages when there's a mistake. I don't know why would you do that. I guess it's fun when you're a teenager, but if you gotta do this for a living, don't do that. Alright, so if it's not, then I think we call that function calc payment, right? We made that function and just pass the parameters. And then we display the monthly payment. So now this matches this. The computer reads top to bottom, so it's executing whatever code's above. If it sees the if statement, it's gonna and determines this is true, it's gonna execute this, and then sees the end curly bracket and jumps out of the if statement. If it's false, then it jumps to the else part and then continues down. Questions? Yeah.
Could you run a else if and then do iterm equals 1 and then run that code, or
I don't understand the question.
like you know how you did if and then you run whatever's in that curly black bracket,
Uh-huh.
and then if you do else, could you do like else if and then like specify if the iterm equals to 1, then you run the else.
Yeah, I'll show you. We're gonna talk about embedded ifs in a second.
Okay.
So, what if I don't want to do anything if it's false? So instead of calculating if it's false, not in this case, but I'll just go straight down. There's no code to execute if it's false. How will you code it? Easy. Don't write an else. So the code only executes if it's true. What if I want to do something if it's only false? What will you do? How will you use it? Well, you have what we call this. Now, this is also called the negation. So, if you want to do false only, put the not in front. You might need another set of parentheses there, but now this code only executes if it's false. Like I said, you said not at the beginning. Or you can do it like this. If you don't want to, if you like to type more, you can do that. That thing equals false. So it becomes true equals false or false equals false. And what if, and you're gonna see this sometimes, what if I only have one line of code to execute if it's true or false? If it's true or false, I only have one line in this case. Some people get rid of the curly brackets. If you do that, you better make sure there's only one line to execute. Because if you have another one, the line 2 will always execute. If it's not intended to execute, then you need to put the curly brackets back. Questions? We good?